November 18, 1995, 11:47 p.m., Blast Furnace C, Bethlehem Steel Corporation, Bethlehem, Pennsylvania. The temperature inside the tap room hovered at 118 degrees Fahrenheit. Outside, the first real snow of winter was falling on the Lehigh Valley, soft, silent, indifferent. Inside, the heat was suffocating. The air tasted of sulfur and iron oxide. Every breath burned. 47 men gathered around the base of Blast Furnace C. Most were in their 50s and 60s, a few younger, sons following fathers into the steel. Tonight, they would tap the final heat of molten steel, the last pour from the last furnace in a complex that once housed 7. Foreman Jack Morrison stood closest to the tap hole, 62 years old, 41 years on this floor. His father had worked this same furnace for 38 years before that. His grandfather, Jack Morrison Sr., had helped build Furnace C in 1914 when he was 23 years old and fresh off the boat from Slovakia. Jack checked his watch. 11:47, 13 minutes until midnight, 13 minutes until the end. Around him, his crew waited. Nobody spoke. What was there to say? They'd said it all over the past weeks. Anger, denial, bargaining, acceptance. Now there was only this. The work, one last time. Above them, the furnace rose 83 feet, 8 stories of refractory brick and steel shell containing 2,000 tons of molten iron at 2,150 degrees Fahrenheit, hot enough to melt stone, hot enough to turn steel into liquid light. "Ready?" Jack called out, his voice flat. The men around him nodded. Tommy Hudak, the second shift keeper, made the sign of the cross. He'd done that before every tap for 33 years. Superstition, he called it. Insurance. Frank Demchak, the youngest at 42, wiped his face with a rag. The rag came away black with soot and sweat. He folded it carefully and put it in his pocket. Later, he would frame it. Proof he'd been here. Proof this had been real. Jack Morrison placed his hand on the tap bar. The metal was warm, always warm, even when the furnace was cold, as if it held memory of every heat ever poured. "All right then," he said quietly. "Let's bring her home." He pulled the lever. 2,700 degrees of liquid steel, glowing so bright it hurt to look at directly, poured from the furnace into a 40-ton ladle. The stream was 3 inches wide and absolutely steady. Perfect control. These men had poured steel together for decades. Their timing was instinctive now, muscle memory written in fire. The heat was overwhelming. Even 15 feet away, the radiant temperature spiked above 150 degrees. The men squinted behind their safety glasses, turned their faces away, but they didn't leave. They'd come to watch this, to witness. 23 minutes. That's how long the final pour would take. 23 minutes to empty the furnace one last time. Jack had poured his first heat on this furnace in 1954. He was 18 years old. His father had stood beside him then, guiding his hands, teaching him the rhythm. "Feel it," his father had said. "The steel tells you what it needs. You just have to listen." Jack had been listening for 41 years. This was the sound that had defined Bethlehem, Pennsylvania for more than a century, the sound of American power, the sound that had armed the nation in 2 world wars, the sound that built the Golden Gate Bridge, the Empire State Building, the George Washington Bridge, the sound of the Cathedral of Steel. In 23 minutes, it would fall silent, forever. But to understand how we arrived at this moment, how a company that once employed 31,000 workers in a single plant, that produced more steel than most countries, that literally built the skeleton of modern America, could collapse into bankruptcy and abandonment, we need to go back. Back to 1857, when a Welshman named Augustus Voll first lit a blast furnace on the banks of the Lehigh River. Back to 1904, when Charles Schwab saw possibility where others saw struggle. Back to 1941, when Bethlehem Steel armed a nation for total war. This is the story of the rise and fall of Bethlehem Steel. This is the story of the men and women who forged America with their hands. This is the story of the cathedral that burned too bright, too fast, and finally went cold. Bethlehem Steel Corporation, founded in 1857 as the Saucona Iron Company on the banks of the Lehigh River in eastern Pennsylvania. Renamed Bethlehem Iron Company in 1861, Reorganized as Bethlehem Steel Corporation in 1904 under Charles M. Schwab. For nearly 150 years, this company forged the infrastructure of modern America. At its peak in 1943, the Bethlehem plant alone employed 31,000 workers. Company-wide, across 15 facilities in 7 states, Bethlehem Steel employed 300,000 people. It was the second largest steel producer in the United States, and in many product categories, structural beams, armor plate, munitions, it was first. The numbers tell one story. 1,127 warships built during World War II. More than any other American company. Structural steel for the Golden Gate Bridge, the Empire State Building, the George Washington Bridge, Madison Square Garden, and dozens of other landmarks. 15% of all American steel production at its height. But numbers don't capture what Bethlehem Steel meant to the people who worked there, to the immigrant families who built lives around those furnaces, to the city of Bethlehem, which grew from 5,000 people in 1900 to 75,000 by 1950, almost entirely because of the plant. This is a story of ambition and innovation, of immigrant labor and American ingenuity, of 2 world wars and the arsenal that armed democracy. But it's also a story of decline, of globalization and automation, of pension obligations and foreign competition, of management failures and market forces. On October 15, 2001, Bethlehem Steel Corporation ceased all operations and filed for bankruptcy. The company that had seemed permanent, inevitable, eternal, vanished. This is how it happened. Charles Michael Schwab was born February 18, 1862, in Williamsburg, Pennsylvania, a small town in the Allegheny Mountains. His father, John Schwab, was a wool merchant, comfortable but not wealthy. Middle class by the standards of post-Civil War America. Young Charlie, everyone called him Charlie, wasn't particularly brilliant in school. He wasn't a prodigy. What set him apart was something harder to quantify: charm. An ability to talk to anyone, day laborers and millionaires alike, and make them believe in whatever he was selling. And Charlie was always selling something. At 17 in 1879, he took a job as a stake driver for Andrew Carnegie's Edgar Thomson Steelworks in Braddock, Pennsylvania, $1 a day. He drove stakes to mark where construction crews should dig. It was unskilled labor, beneath notice. 6 months later, he was supervising a crew. Within a year, he was managing an entire department. By 1886, at age 24, he was superintendent of the Edgar Thomson Works, the largest steel mill in America. Andrew Carnegie, the steel titan himself, had noticed something in young Schwab. Not just competence, though Charlie was supremely competent. Not just ambition, though God knows he had that. What Carnegie saw was a rare combination: vision married to practicality. Schwab could dream big, but he could also calculate costs per ton and manage thousands of men. Carnegie promoted Schwab repeatedly. By 1897, at 35 years old, Charles Schwab became president of Carnegie Steel Company, the largest steel producer in the world. But Charlie Schwab wanted more. Carnegie Steel was massive, profitable, dominant, but it belonged to Andrew Carnegie. Schwab was an employee, highly paid, enormously powerful, but still an employee. He wanted something that was his. In 1901, Schwab orchestrated the deal of the century. He convinced banker J.P. Morgan to buy Carnegie Steel for $480 million, approximately $17 billion in today's dollars. Morgan combined Carnegie Steel with several smaller companies to form United States Steel Corporation, the first billion-dollar corporation in American history. Schwab became U.S. Steel's first president. Salary, $1 million per year. Power, immense. Control, limited. And that was the problem. J.P. Morgan ran U.S. Steel from his office in New York. He cared about quarterly dividends and stock prices. Schwab cared about steel, the making of it, the science of it, the art of it. The two men clashed constantly. By 1903, Schwab had had enough. He resigned from U.S. Steel, citing health concerns. The real reason: he couldn't build his own empire while working for Morgan's. He found his opportunity 100 miles north in Bethlehem, Pennsylvania. The Bethlehem Iron Company had existed since 1857, founded by Augustus Voll, a Welshman who'd built a small blast furnace on the Lehigh River. The company made railroad rails, structural iron, and small forgings. It was respectable, modestly profitable, utterly unremarkable. By 1904, when Schwab started buying shares, Bethlehem Iron was struggling. Its technology was outdated, its management was conservative, its profits were thin. But Schwab saw what others didn't: potential. The location was perfect. The Lehigh River provided water transportation, railroad lines crisscrossed the area, iron ore could be shipped from the Great Lakes. Coal came from Pennsylvania mines 30 miles away. The infrastructure was already in place. The workforce was skilled. German and Eastern European immigrants, men who knew metalworking, who understood furnaces and rolling mills. They were hard-working, disciplined, and cheap. Not cheap in a cruel sense. Schwab would pay his workers well, but cheap compared to union labor in Pittsburgh or Chicago. And the market was growing. America was building. Skyscrapers in New York, bridges across rivers, railroads to every corner of the country. All of it required steel, enormous quantities of steel. Schwab moved decisively. By 1904, he'd purchased controlling interest in Bethlehem Iron. He renamed it Bethlehem Steel Company. He installed himself as president, and he began to transform it. His first major investment, $5 million, $160 million today, to install the gray mill system. This was revolutionary technology imported from Britain. A massive rolling mill that could produce structural steel beams longer and stronger than anything American mills could make. Other steel executives thought Schwab was insane. $5 million on unproven foreign technology? Schwab's response was simple: quality will sell itself. He was right. In 1907, Bethlehem Steel won the contract to supply structural beams for Pennsylvania Station in New York City. The project required beams 60 feet long, weighing 8 tons each, capable of supporting thousands of tons of load. No American mill could produce them to specification, except Bethlehem. The gray mill rolled beams that were 30% stronger at 20% less weight. They arrived on time, within tolerance, and under budget. Pennsylvania Station, a magnificent Beaux-Arts cathedral of transportation, was built on Bethlehem Steel. It was a masterclass in marketing. Every architect, every engineer, every builder in America saw Penn Station and asked, "Who made that steel?" The answer: Bethlehem. Orders flooded in. The Williamsburg Bridge, the Woolworth Building, Grand Central Terminal, every major construction project in the Northeast wanted Bethlehem Steel. But Schwab wasn't satisfied with structural steel alone. In 1913, he made his second transformative move. He secured a contract with the United States Navy to produce armor plating for battleships. This changed everything. Armor plate was enormously profitable. The Navy paid premium prices because so few companies could produce it. More importantly, it required precision, advanced metallurgy, and massive capital investment. It created a barrier to entry that protected Bethlehem from competitors. By 1914, when World War I erupted in Europe, Bethlehem Steel was one of only 3 American companies capable of producing naval armor. And of those 3, Bethlehem was the best. When Britain, France, and Russia came looking for steel, mountains of steel, to feed the insatiable appetite of industrial warfare, they came to Charles Schwab. He was ready. Bethlehem Steel's revenue in 1914, $48 million. Bethlehem Steel's revenue in 1918, $495 million, and tenfold growth in 4 years. Charles Schwab had built his empire, and the world was about to need everything it could produce. When Charles Schwab took control of Bethlehem Steel in 1904, the plant covered 45 acres along the Lehigh River, 2 blast furnaces, 3 open hearth furnaces, 1 rolling mill, employment, 5,000 workers. Respectable, but far from remarkable. Schwab had bigger plans. His strategy was simple in concept, brutal in execution: invest everything in capacity and technology, borrow heavily, build aggressively, bet that demand would come. Between 1904 and 1913, Schwab poured nearly $30 million into expansion, roughly $900 million in today's dollars. For a company that had been barely profitable when he bought it, this was an enormous gamble. He started with infrastructure. The original Bethlehem plant had been built piecemeal over 50 years. Buildings were scattered, materials moved inefficiently, workers walked hundreds of yards between operations. Schwab redesigned everything. He hired Frederick Taylor, the father of scientific management, to study workflow and eliminate waste. Taylor's team spent 6 months with stopwatches, measuring every movement, every delay, every inefficiency. The result was a complete reorganization. New buildings were constructed in a logical sequence. Raw materials flowed in one end, finished steel emerged from the other. No backtracking, no wasted motion. Materials moved on dedicated railways. Bethlehem built its own internal rail system, eventually covering 50 miles of track within the plant grounds. Storage was centralized. Bethlehem constructed massive stockyards along the river, 20 acres of organized chaos where iron ore, coal, and limestone were sorted by quality and stored for immediate access. Great Lakes ore boats could unload directly into these yards. Trains from Pennsylvania coal mines backed up to designated spots. Everything was cataloged, tracked, measured. This level of organization was unprecedented in American steelmaking. Most mills were still running on 19th century methods, materials piled wherever there was space, workers scrambling to find what they needed. Bethlehem operated like a machine. Schwab liked to say, a steel mill should run like a watch, every part in its place, every motion purposeful. But infrastructure was only the beginning. Schwab's real focus was production capacity. Between 1906 and 1910, he added 4 new blast furnaces. Each was larger than the ones it replaced. The newest, Furnace G, stood 75 feet tall and could produce 800 tons of pig iron every 24 hours, double the output of the original furnaces. He expanded the open hearth department from 3 furnaces to 14. Each new furnace could hold 200 tons of molten steel. The building that housed them, the open hearth shop, stretched 900 feet long and rose 60 feet high. Workers called it the cathedral, a vast space of steel columns and brick walls, heated to infernal temperatures, filled with the roar of forced air and the glow of molten metal. And then there was the gray mill, Schwab's showcase, the $5 million bet that everyone said would bankrupt him. The mill consisted of a series of massive rollers, each 12 feet in diameter, arranged in sequence. Steel ingots, blocks weighing up to 15 tons, were heated to 2,200 degrees Fahrenheit in adjacent furnaces, then passed through the rollers. With each pass, the steel was compressed, elongated, shaped. What went in as a crude block emerged as a precision-engineered structural beam, an I-beam, an H-beam, a channel, capable of supporting thousands of tons of weight. The gray mill could roll beams up to 80 feet long. No other American mill could match that. More importantly, it could maintain tolerances within 1/16 of an inch over that entire length. For structural steel, precision mattered. A beam that was slightly off-spec could fail under load. People could die. Bethlehem's beams didn't fail. Word spread through the construction industry. By 1910, if you were building something important, something tall, something permanent, you specified Bethlehem Steel. The Manhattan Municipal Building, the Woolworth Building, which would become the tallest building in the world in 1913, the Hell Gate Bridge in New York with its massive steel arch spanning 1,000 feet, all Bethlehem Steel. Every completed project was an advertisement. Every architect who toured a Bethlehem-framed building became a client. But Schwab's most important decision came in 1913, the Navy contract. The United States was expanding its fleet. President Theodore Roosevelt had launched the Great White Fleet in 1907, 16 battleships sent around the world to demonstrate American naval power. But by 1913, those ships were already obsolete. Britain and Germany were building dreadnoughts, massive, heavily armored warships mounting 10 or 12 large-caliber guns. America needed dreadnoughts, and dreadnoughts needed armor. Naval armor was extraordinarily difficult to produce. It required nickel-steel alloy, heat-treated under precise conditions. The steel had to be hard enough to resist shells, but not so brittle that it would shatter on impact. It had to be manufactured in enormous plates, sections weighing 30 tons or more, with uniform properties throughout. Only 3 American companies could do it: Carnegie Steel, now part of U.S. Steel, Midvale Steel, and Bethlehem. Schwab saw opportunity. He invested another $300 million today in armor plate facilities, new forging presses, new heat-treating furnaces, new testing equipment. He hired the best metallurgists in America, offering salaries that U.S. Steel couldn't match. By 1914, Bethlehem could produce armor plate faster, cheaper, and better than anyone else in America. The Navy noticed. So did the British Admiralty and the French Ministry of Marine. When war came to Europe in August 1914, Bethlehem Steel was perfectly positioned. Employment had grown from 5,000 in 1904 to 12,000 in 1914. The plant now covered 200 acres. Production capacity had increased sixfold. Revenue had climbed from $10 million in 1904 to $48 million in 1914. Impressive growth. But Schwab knew these numbers would soon seem quaint, because modern war consumed steel at rates that peacetime couldn't imagine. Artillery shells by the millions, rifles by the hundreds of thousands, barbed wire by the ton, armor plate, ship hull steel, railway tracks, helmets. Every weapon, every vehicle, every fortification required steel. And the European powers, locked in total war, their own steel mills bombed or overextended, would pay almost any price to get it. Schwab called a meeting of his senior managers in September 1914. The war was 1 month old. Already, orders were flooding in from Britain and France. "Gentlemen," Schwab said, "we're going to need more furnaces." It was the understatement of the decade. August 1914, the Guns of August, they would call it later. Germany invaded Belgium. Britain and France declared war. Within weeks, the Western Front stretched from the English Channel to the Swiss border, 450 miles of trenches, barbed wire, and mud. And the war consumed steel. Artillery shells. Each major offensive fired millions of them. The Battle of Verdun in 1916 would see 40 million shells fired in 10 months. Each shell required a precisely machined steel casing, barbed wire, hundreds of miles of it strung across no man's land. Before the war, barbed wire was used to fence cattle. Now it became a weapon: rifles, machine guns, helmets, railway tracks to move troops and supplies, steel plate for tanks. The British would introduce them in 1916, armor for ships, steel everywhere in quantities no one had imagined possible. Europe's steel mills tried to keep pace, but they were overwhelmed. German submarines hunted supply ships, factories were bombed, workers were conscripted into armies. Production collapsed even as demand exploded. The Allies turned to America, and in America, they turned to Bethlehem Steel. The orders started small in late 1914. A few thousand tons of steel plate for British ships, some artillery shells for France, inquiries about production capacity. By early 1915, the flood began. Britain ordered 1 million artillery shells. Delivery, 6 months. Price, $20 million. France ordered armor plate for 3 battleships. Delivery, immediate. Price, whatever it costs. Russia ordered rifles, machine guns, and 100,000 tons of steel rail to rebuild supply lines. Charles Schwab faced a problem. Not whether to accept the orders, of course he'd accept them, but whether Bethlehem could physically produce what was being ordered. His solution was simple: expand again. Faster than before. Larger than before. Between 1915 and 1917, Bethlehem Steel added 3 new blast furnaces, 8 new open hearth furnaces, 2 new rolling mills, a dedicated munitions plant covering 40 acres, housing for 5,000 additional workers. The plant operated 24 hours a day, 7 days a week. There were no holidays, no weekends. The furnaces never cooled. Workers poured in from across America and Europe: Italians from Philadelphia, Poles from Chicago, Slovaks and Hungarians straight from Ellis Island, Greeks, Russians, Lebanese. By 1917, workers at Bethlehem Steel spoke 23 different languages. Pay was excellent by the standards of the era: $4.50 per day for laborers, double the national average for manufacturing work. Skilled workers, melters, rollers, crane operators, earned $6 to $8 per day. Foremen earned $10. This wasn't generosity. Schwab needed workers, and he needed them to stay. Training a blast furnace operator took months. Training a roller took years. Turnover was expensive. High wages reduced turnover. The work was brutal. 10-hour shifts later extended to 12 hours when demand peaked. Temperatures in the furnace rooms exceeded 120 degrees Fahrenheit in summer. The noise was constant. The roar of furnaces, the crash of steel on steel, the hiss of steam. Men shouted to communicate. Many lost their hearing by age 40. Injuries were common: burns from molten metal, crushed limbs from equipment, falls from catwalks. Bethlehem built a company hospital in 1969. It had 50 beds. They were always full. The death rate was approximately 1 fatality per 1,000 workers per year. In 1917, with 20,000 workers, that meant 20 deaths, 20 families receiving telegrams, 20 funerals. The company paid $1,000 to families of deceased workers, generous for the time, insulting in retrospect. Widows had 30 days to vacate company housing, but the steel kept flowing. By 1916, Bethlehem Steel was producing 60% of all artillery shells purchased by Britain and France, 70% of armor plate used by the U.S. Navy, 40 million pounds of gun forgings, structural steel for shipyards building merchant vessels and warships. The Four River Shipyard in Massachusetts, owned by Bethlehem, launched destroyers and submarines at unprecedented rates. The company built 52 ships during the war, including the USS Texas, one of the most powerful battleships in the American fleet. When the United States entered the war in April 1917, demand intensified. Now, Bethlehem was supplying the American military directly, plus continuing contracts with Britain and France. Production reached levels that seemed impossible. In 1917 alone, Bethlehem Steel produced 4.5 million artillery shells, 700,000 tons of steel plate, 12 million pounds of forgings, and 6 warships. Charles Schwab traveled to Washington repeatedly, meeting with military officials and government procurement officers. He promised the moon and delivered it. "Give us the orders," he told Secretary of War Newton Baker in 1917. "We'll find a way to fill them." The financial results were staggering. Revenue in 1914, $48 million revenue in 1915, $150 million revenue in 1916, $265 million revenue in 1917, $385 million revenue in 1918, $495 million. Profit margins were enormous. Bethlehem's profit in 1917 was $62 million, a 16% margin. Critics called it profiteering. A Senate investigation in 1918, led by Senator Robert La Follette, accused Schwab of exploiting the war for personal gain. Schwab defended himself before Congress. "We sell steel at market prices," he testified. "If those prices are high, it's because demand exceeds supply. We didn't create this war. We're helping win it." The senators were unconvinced, but the hearings went nowhere. The war needed steel. Bethlehem produced steel. Politics couldn't change that reality. By November 11, 1918, when the armistice was signed, Bethlehem Steel had fundamentally transformed. Employment had grown from 12,000 in 1914 to 25,000 in 1918. The plant covered 500 acres. Production capacity had doubled again. The company was now the second largest steel producer in America, trailing only U.S. Steel. In certain products, armor plate, structural beams, munitions, Bethlehem was first. More importantly, Bethlehem had proven something crucial. American industry could outproduce the world. When the world needed steel, desperately, immediately, America delivered. Charles Schwab was now one of the wealthiest men in America. His personal fortune exceeded $200 million, approximately $4 billion today. But the victory came with a cost that wouldn't be fully understood for decades. The war had been good for Bethlehem Steel. Too good. The company had grown accustomed to guaranteed government contracts, premium prices, and unlimited demand. What would happen when peace came? When the world no longer needed millions of shells and thousands of tons of armor plate? Schwab believed the answer was obvious. America would build roads, bridges, buildings, infrastructure. The steel that had armed the nation would now construct it. He was right. The 1920s would be a second golden age. But the habits formed during the war, the assumption that demand would always exist, that prices would always be high, that growth was permanent, would ultimately prove fatal. For now, though, in November 1918, Bethlehem Steel stood triumphant. The arsenal that had helped defeat the Kaiser, the company that had forged victory. The cathedral was complete, and it was magnificent. The 1920s began with uncertainty. The war was over. Defense contracts evaporated overnight. Millions of soldiers returned home, flooding the labor market. A recession hit in 1920 or 1921. Steel demand collapsed. Many steel companies struggled. Some failed entirely. Bethlehem Steel thrived. Charles Schwab had anticipated the transition. While other companies cut capacity and laid off workers, Schwab reinvested war profits into peacetime infrastructure. His bet: America would build in the 1920s like never before. He was spectacularly right. Between 1922 and 1929, America experienced an infrastructure boom. Cities grew upward. Skyscrapers sprouted in every major urban center. Bridges spanned rivers that had never been crossed. Highways connected coast to coast. Railways expanded. Factories multiplied. All of it required steel. And the best steel, the strongest, most reliable, most precisely engineered, came from Bethlehem. Schwab used war profits to finance the most ambitious expansion in the company's history. Between 1920 and 1929, Bethlehem Steel invested $180 million, approximately $3 billion today, into the Bethlehem plant alone. The result was a complex that defied easy description. It wasn't just a factory, it was an industrial city unto itself. By 1925, the Bethlehem plant covered 200 acres, nearly 2 square miles. The complex included 27 blast furnaces, each capable of producing 1,000 tons of pig iron every 24 hours. They stood in a row along the river, their stacks rising 80 to 100 feet into the sky. At night, they glowed like enormous torches. The light could be seen from 20 miles away. 58 open hearth furnaces where pig iron became steel. The open hearth building, expanded multiple times, now stretched half a mile long. Inside, temperatures reached 2,800 degrees Fahrenheit. The heat was so intense that managers worked from elevated air-cooled control rooms. Even with cooling, the temperature in those rooms rarely dropped below 95 degrees. 14 rolling mills, each specialized for different products. The gray mill still dominated structural beam production. New mills handled plate steel, rail steel, sheet steel, wire. The largest, Mill Number 9, was 800 feet long, 6 football fields laid end-to-end, 140 buildings connected by skywalks, tunnels, and railways. Materials moved constantly. Ore arrived by boat, coal came by train, limestone was trucked in from nearby quarries. Everything flowed toward the furnaces, was transformed, and emerged as finished steel. 300 miles of internal railway track. Bethlehem owned more railway mileage than some small railroads. Dedicated locomotives, 37 of them, moved materials around the clock. The switching yards covered 20 acres, its own power plant generating 250,000 kilowatts, enough electricity to power a city of 100,000 people. The plant consumed so much power that connecting to the public grid was impractical. Bethlehem generated everything it needed, its own water system pumping 60 million gallons per day from the Lehigh River. Steel production required enormous quantities of water for cooling, for steam, for cleaning. The company built its own filtration plant, its own pumping stations, its own distribution network. The administration building, completed in 1917, rose 21 stories, the tallest building in Pennsylvania outside Philadelphia. From the top floor, executives could survey the entire operation. On a clear day, you could see the Pocono Mountains to the north and the Delaware Water Gap to the east. The building wasn't just functional, it was a statement. The lobby featured Italian marble floors, bronze fixtures, and a 3-story atrium. Oil paintings of Charles Schwab and previous company presidents lined the walls. Mahogany paneling and executive offices. This was a cathedral of capitalism, and it looked the part. Even the worker facilities reflected Schwab's philosophy of enlightened paternalism. The locker rooms had tile floors and steel lockers, rare luxuries in industrial facilities of that era. The company cafeteria served hot meals at subsidized prices. The company hospital, expanded in 1923, now had 120 beds and employed full-time doctors and nurses. Schwab understood symbolism. The plant was more than a place to make steel. It was a monument to industry, to American power to progress itself. Visitors came from around the world, engineers from Germany studying American methods, Japanese industrialists taking notes, Soviet officials investigating capitalist production techniques. Charles Schwab personally led tours for dignitaries, his enthusiasm never dimming even as he entered his 60s. "This," he would say, gesturing to the furnaces, "is where we build the future." The public relations value was immense. Schools brought students to tour the plant. Local newspapers ran features on the steel giant of the Lehigh Valley. National magazines profiled Schwab as a captain of industry. The plant appeared in newsreels, textbooks, and advertisements. Bethlehem Steel marketed itself as the backbone of America and backed it up with a list of iconic structures. By 1929, Bethlehem structural steel had been used in the Chrysler Building in New York, completed in 1930, briefly the world's tallest building. The distinctive Art Deco spire, all 19 stories of it, was pure Bethlehem steel. The George Washington Bridge, connecting New York and New Jersey. When it opened in 1931, it was the longest suspension bridge in the world. Bethlehem supplied 47,000 tons of steel for the towers and cables. Rockefeller Center, the massive complex in Midtown Manhattan, 14 buildings all framed with Bethlehem steel. The San Francisco-Oakland Bay Bridge, an engineering marvel spanning 8.4 miles. The project consumed 175,000 tons of Bethlehem steel, the largest single order in company history. Madison Square Garden, Grand Central Terminal, the Philadelphia Museum of Art, bridges across the Mississippi, the Ohio, the Susquehanna, buildings in every major American city. Each project was a testament. Each structure bore the Bethlehem steel stamp, sometimes literally. The company branded its structural beams with the name Bethlehem stamped into the metal. On many buildings, if you climbed into the framework, you could still read those stamps decades later. The marketing wrote itself. When architects specified Bethlehem steel on blueprints, they weren't just ordering a product, they were buying a legacy. By 1929, employment at the Bethlehem plant had reached 26,000 workers. The company operated 15 plants nationwide, employing 60,000 total. Revenue exceeded $250 million annually. Charles Schwab, now 67 years old, surveyed his empire with satisfaction. From a struggling iron company in 1904 to the second largest steel producer in America in 1929. 25 years of relentless growth. But Schwab was already thinking ahead. The 1930s would bring challenges. He knew that. The stock market had crashed in October 1929. A recession was coming, perhaps a serious one. But Bethlehem Steel had weathered downturns before. The company was strong. Its reputation was unmatched. Its facilities were modern. Its workforce was skilled. Whatever the 1930s brought, Schwab believed Bethlehem would emerge stronger. He was partially right. The company would survive the Great Depression, but the world was changing in ways even Charles Schwab couldn't anticipate. The cathedral was magnificent, but cathedrals, however grand, are still built on foundations. And some foundations, given enough time and pressure, begin to crack. To understand Bethlehem Steel, you have to understand how steel is made, not in theory, but in practice, not as chemistry, but as orchestrated violence. The process began at the ore docks on the Lehigh River. Great Lakes freighters arrived weekly, each carrying 10,000 tons of iron ore from the Mesabi Range in Minnesota, the richest iron deposits in North America. The ore came in reddish-brown chunks, 60% pure iron, mixed with rock and oxygen. Massive cranes, the largest could lift 20 tons at a time, unloaded the ore into stockyards covering 20 acres. Workers sorted it by quality. High-grade ore went to one pile, lower grade to another. Everything was cataloged, nothing was wasted. Nearby, coal arrived by train from Pennsylvania mines. Not regular coal, coke. Coal that had been baked in airless ovens at 2,000 degrees for 18 hours, driving off impurities and leaving nearly pure carbon. Coke burned hotter and cleaner than raw coal. Steel production required it. Limestone came from local quarries, crushed into fist-sized chunks. Its role, flux. It would bind with impurities in the ore and draw them off as slag. These three ingredients, iron ore, coke, limestone, were the recipe. Everything else was heat and timing. The first step, the blast furnace. Imagine a structure 80 feet tall, shaped like a massive bottle. The walls, 3 feet of refractory brick wrapped in a steel shell. Inside, a crucible capable of holding 2,000 tons of molten iron. The process was continuous. The furnace never shut down. Stopping meant cooling, and cooling meant weeks of downtime to reheat and restart. So the furnaces ran 24 hours a day, 365 days a year, for decades at a time. Furnace C, where Jack Morrison would tap the final heat in 1995, had been in continuous operation since 1914. 81 years without stopping. Raw materials loaded into the top. A skip hoist, basically an enormous elevator, carried measured amounts of ore, coke, and limestone up the outside of the furnace and dumped them through the top. The ratio was precise: 1 ton of coke, 2 tons of ore, half a ton of limestone. At the bottom of the furnace, massive blowers forced superheated air through pipes called tuyères, iron tubes that glowed white-hot from the heat. The air blast gave the furnace its name. The temperature inside reached 3,000 degrees Fahrenheit. Chemistry took over. The coke burned in the oxygen-rich air, producing carbon monoxide. The carbon monoxide rose through the furnace, stripping oxygen from the iron ore. The iron melted and trickled down to the bottom, pooling in the hearth, the crucible at the furnace base. The limestone melted too, binding with rock impurities to form slag, a glassy waste material that floated on top of the molten iron like oil on water. Every 6 hours the furnace was tapped. A crew used a pneumatic drill to punch through a clay plug at the base of the hearth. Molten iron, now called pig iron, poured out through a trough into a ladle holding 100 tons. The iron glowed orange-white, almost too bright to look at. The temperature, 2,800 degrees. Above the iron, slag flowed into a separate channel. The slag was waste, but valuable waste. It was sold to cement manufacturers and road builders. Nothing was discarded. The ladle, mounted on a railway car, moved to the open hearth building. Here, pig iron became steel. Pig iron contained too much carbon, about 4%. It was brittle, unsuitable for construction. Steel required less than 1% carbon, plus precise amounts of manganese, silicon, and other elements. The open hearth furnace was a shallow pool of molten metal, 60 feet long and 20 feet wide, holding 200 tons. Flames roared across the surface at 2,800 degrees, kept at temperature by burning natural gas. Pig iron poured in. Scrap steel, recycled from previous production, was added. Then, the critical step. Oxygen was blown through the molten metal. The oxygen burned off excess carbon. The carbon escaped as carbon monoxide gas. What remained was steel. The process took 8 to 12 hours. Operators, called melters, monitored it constantly, testing samples every 30 minutes. When the chemistry was right, carbon below 1%, manganese and silicon within specification, the heat was ready. The melter signaled. The furnace tilted like a giant teapot, pouring 200 tons of glowing liquid steel into a ladle. Steam and smoke filled the building. The roar was deafening. The ladle moved again, this time to the casting area. The steel poured into molds, large rectangular forms made of cast iron. As the steel cooled, it solidified into ingots, blocks weighing 10 to 15 tons each. The ingots were still hot, around 800 degrees, when cranes lifted them and moved them to the soaking pits. These were essentially enormous ovens that kept the ingots at uniform temperature. Steel had to be worked while hot. If it cooled too much, it would crack when rolled. From the soaking pits, the ingots went to the rolling mills. This was where steel became useful. The gray mill, Bethlehem's pride, consisted of a series of rollers, each 12 feet in diameter. An ingot entered on a conveyor. It passed through the first set of rollers, which squeezed it, compressing it lengthwise. It traveled to the second set of rollers, positioned at a right angle, which squeezed it again. back and forth through multiple passes, each time a little thinner, a little longer, gradually taking shape. The steel remained red-hot throughout, around 2200 degrees. If it cooled too much, it went back to the heating furnace. Temperature control was everything. After the final pass, what emerged was a structural beam, an I-beam 60 feet long, weighing 3 tons, shaped to precise specifications within 1/16 of an inch tolerance. The beam cooled on the runout table, a long conveyor that allowed it to cool slowly and evenly. Too fast cooling caused warping or cracking. Once cooled, the beam went to the finishing department. Here, workers used cutting torches to trim the ends to exact length. Grinders smoothed rough spots. Inspectors checked dimensions with calipers and micrometers. Every beam was tested, struck with a hammer to check for internal flaws. A good beam rang clear. A flawed beam sounded dead. Finally, the Bethlehem Steel stamp was applied, the company name forged directly into the metal. Then loading. Cranes lifted the finished beams onto railway flat cars for shipping. The entire process, from ore boat to finished beam, took approximately 72 hours. At peak production in the 1940s, Bethlehem processed 10,000 tons of raw ore per day and produced 3,000 tons of finished steel products. It was an orchestra of fire and metal. Dozens of processes, hundreds of workers, thousands of precise decisions. Everything had to work in harmony. A breakdown at any stage halted everything downstream. And it worked, day after day, year after year, decade after decade. The machine was magnificent, and for 50 years it was unstoppable. But machines wear out, and the world was building newer, more efficient machines. Bethlehem Steel's management would learn this truth too late. John Kovacs woke at 5:15 every morning. Not to an alarm clock, he couldn't afford one until 1937, but to his body's internal rhythm, trained by 20 years of day shift. His apartment was 2 rooms on the second floor of a company-owned building on 4th Street in South Bethlehem. Rent, $18 a month, 2 bedrooms, one for John and his wife Anna, one for their 4 children, a kitchen with a coal stove, a shared bathroom down the hall used by 3 families. By 5:30, Anna had coffee ready, real coffee, not chicory. That was one benefit of steady work at Bethlehem Steel. You could afford small luxuries. John ate breakfast in silence, rye bread with lard, a piece of cheese, an apple. Anna packed his lunch pail, more bread, a hunk of kielbasa, an onion, a thermos of coffee. The lunch pail was dented steel, his name scratched on the bottom. He'd carried it for 15 years. At 6 gear, he left the apartment. Anna watched him go, same as every morning. She never said, "Be careful," or "Come home safe." Those words were bad luck. Instead, "I'll have dinner ready at 4. John walked the 0.8 of a mile to the plant gate. He was 42 years old in 1935. He'd started at Bethlehem at age 18 in 1911, the year he arrived from Hungary. 24 years, minus 6 months laid off during the 1921 recession. The walk took 15 minutes. In winter, he walked in darkness. In summer, the sun was just rising, turning the blast furnace smoke pink and orange. At the gate, he clocked in. 6:45. Late meant no pay for the first hour. 3 times late in a month meant termination. John was never late. He was a blast furnace helper assigned to Furnace D. His job, assist the keeper in tapping the furnace, managing the flow of molten iron, and maintaining the tapping equipment. It required strength, coordination, and an absolute focus on not dying. The day shift ran from 7 in the morning to 3 in the afternoon, 8 hours, with one 15-minute break at 10:30. The work began the moment John arrived at Furnace D. The keeper, his supervisor, a German named Hans Weber, was already there, checking pressure gauges and temperature readings. "Morning, John," Weber said, not looking up. "Morning." That was the extent of their conversation most days. The furnace was too loud for small talk. Communication happened through hand signals and practiced routine. At 7:30, the first tap of the day, John positioned the ladle, a railway car with a massive steel crucible holding 100 tons. Weber operated the drill that punched through the clay plug sealing the furnace. The plug broke. Molten iron erupted. The heat was immediate and overwhelming. Even 15 feet away, even with protective gear, John felt like he was standing in front of an opened oven. The temperature spiked to 140 degrees. His face burned. Sweat poured. The iron flowed for 20 minutes. John's job: monitor the stream, watch for irregularities, signal if anything looked wrong. The iron had to flow clean and steady. Any sputtering or splashing meant trouble, a blockage, a dangerous buildup of pressure. This time, it flowed clean. When the tap finished, Weber closed it off with a pneumatic clay gun, essentially a cannon that shot clay plugs into the tap hole. Then, they had 2 hours until the next tap. John spent that time maintaining equipment, cleaning tuyères, the air blast pipes, which got clogged with debris, replacing worn fittings, shoveling slag from the previous tap into railway cars for removal. The work was physically brutal. John lifted, pushed, and pulled all day. By age 42, his back ached constantly. His hands were scarred from burns, minor ones, the kind you got weekly. His hearing was damaged. The constant roar of the furnace had stolen the high frequencies. He could barely hear his youngest daughter's voice. At 10:30, the break. 15 minutes. John walked outside, sat on a bench, ate half his lunch. He didn't talk to the other workers. Most were too tired to talk. They sat in silence, grateful for the cool air. Back to work at 10:45. Another tap at 11 cool. Then routine maintenance. Then the final tap of the day shift at 2 Delao. At 3 Salno, John clocked out. 8 hours, $6.40 earned, 80 cents per hour. It was good pay. The national average for manufacturing in 1935 was 50 cents per hour. Bethlehem paid 60% above average. But the money came at a cost. The average life expectancy for a blast furnace worker at Bethlehem was 58 years. The national average was 65. Those 7 missing years were paid in heat, in toxic fumes, in physical destruction. John Kovacs would work at Bethlehem Steel for 41 years total. He would retire in 1952 at age 59, his body worn out. He would die in 1967 at age 74, 16 years past the life expectancy for men in his job. He was lucky, not everyone was. In 1935, Bethlehem Steel employed 26,000 workers at the main plant. That year, there were 23 workplace fatalities, 23 men who left for work in the morning and never came home. The causes varied: crushed by equipment, burned by molten metal, falls from catwalks, explosions from gas pockets, electrocution. When a man died, the company paid $1,000 to his family, about 18 months of wages. The widow had 30 days to vacate company housing. There was no pension for her, no continued health coverage, nothing. The funerals were always the same. The deceased's crew attended. They were given 4 hours off with pay. The priest spoke about eternal rest and God's plan. The widow cried. The children looked confused. And the next morning, a new worker took the dead man's place. This was the bargain. Bethlehem Steel paid well, provided steady work, and offered benefits that were generous for the era. In exchange, you gave your body, your hearing, your health, and sometimes your life. Most workers accepted it. What choice did they have? John's son, John Jr., started at Bethlehem in 1942 at age 18. He worked the same furnace as his father. When John Sr. retired in 1952, John Jr. was still there. He would work at Bethlehem for 33 years until the layoffs began in 1985. This was the pattern. Fathers brought sons, uncles brought nephews. Entire families worked there. Entire neighborhoods revolved around shift schedules. In South Bethlehem, you could tell time by the shift changes. At 7 km, 3 p.m., and 11 p.m., thousands of men flooded the streets, going to work, coming home. The bars filled at 3:15 when day shift ended. The churches held 6 a.m. masses for night shift workers getting off. The work defined everything. When you met someone in Bethlehem, the first question wasn't, "What do you do?" but "What department?" Everyone worked at the steel plant. The only question was where. This created a bond, a shared understanding. These men had seen each other at their worst, exhausted, injured, afraid. They'd covered for each other when someone was sick. They'd helped each other when money was tight. They didn't socialize much outside work, too tired, too busy with families. But they were brothers in a way civilians couldn't understand. The steel bound them together. It gave them purpose, identity, pride. When you worked at Bethlehem Steel, you built America. The bridges you crossed, the buildings you saw, the ships that protected the country, you made those with your hands, with your sweat. with your blood. That knowledge carried you through the heat, the danger, the exhaustion. You were part of something larger, something that mattered. At least, that's what they told themselves. And for 50 years, it was true. Charles Schwab died in 1939, but his philosophy shaped Bethlehem Steel for decades after. He called it enlightened paternalism. Take care of your workers, and they'll take care of production. Treat them decently, pay them fairly, provide stability, and they'll give you loyalty. It wasn't altruism, it was strategy. Training a skilled steelworker took years. Turnover was expensive. High wages and benefits reduced turnover. The math was simple, but the effect went deeper than Schwab probably intended. Bethlehem Steel didn't just employ people. It created a culture, a way of life. The company offered benefits that were extraordinary for the 1920s and 1930s. Health insurance, 80% covered by the company. A company doctor on site who treated injuries and illnesses for free. A dental clinic, an eye care center. Pensions. After 30 years of service, a worker received $100 per month for life, about $2,000 in today's dollars. It wasn't luxury, but it was security. You could retire and survive. Life insurance. Every worker received a $5,000 policy paid for by the company. If you died, your family received that money. It was often the only wealth a worker ever accumulated. Paid vacation. 1 week after 5 years of service, 2 weeks after 15 years. This was radical in an era when most factory workers got no paid time off at all. But the benefits went beyond compensation. Bethlehem Steel built a social infrastructure. In 1918, the company established the Bethlehem Steel Recreation Association. The company funded it with annual contributions of over $100,000, roughly $3 million today. The association built and maintained facilities across South Bethlehem, a gymnasium with a full-size basketball court, 12 baseball diamonds. The company sponsored 30 teams in an internal league. Bowling alleys, a swimming pool, a community center with a library containing 12,000 books. Every summer, Bethlehem Steel shut down the plant for 1 day, the annual company picnic. Every employee and their family was invited. 26,000 workers, 60,000 people with families included, free admission, free food, games, contests, prizes. The local newspapers covered it like a major civic event. Because it was. 1/10 of Bethlehem's population gathered in one place, eating hot dogs and playing baseball. It was good PR. It was also genuine community building. Workers from different departments met. Kids played together. Families relaxed for 1 day, away from the heat and danger of the plant. The company also invested in education, free English classes for immigrant workers held in company facilities after shifts, technical training programs in metallurgy, mechanical engineering, and industrial management, high school equivalency courses for workers who'd never finished school. This wasn't charity. Educated workers were more valuable. A blast furnace operator who understood chemistry could make better decisions. A maintenance worker who could read technical manuals was more efficient. But it was also opportunity. Dozens of workers rose from the floor to management through these education programs. The company preferred promoting from within. They understood operations better than any outside hire. Bethlehem Steel also built housing. By 1930, the company owned 2,800 residential units in neighborhoods surrounding the plant. Small homes, 2 bedrooms, 1 bathroom, a kitchen. Basic but solidly constructed. Rent, $18 to $25 per month, subsidized by the company to keep costs low. This wasn't entirely altruistic either. Company housing kept workers close to the plant. If a furnace broke down at 2 a.m., management could reach workers in minutes. It also created dependency. Lose your job, lose your home. But for immigrant families with nowhere else to go, it was stability. The company's influence extended into every corner of Bethlehem, Pennsylvania. By 1930, the city's population had reached 60,000. Of those, 26,000 worked directly for Bethlehem Steel. Another 20,000, family members, shop owners, service workers, depended indirectly on steel wages. Bethlehem Steel was the largest taxpayer, contributing 40% of the city's revenue. the largest landowner, the largest employer by a factor of 10. When Bethlehem Steel thrived, the city thrived. When the company struggled, everyone felt it. The local economy existed to serve steelworkers. In South Bethlehem alone, there were 47 bars, 12 butcher shops, 23 grocery stores, many specializing in ethnic foods, Polish, Hungarian, Greek, Italian, 7 churches, Catholic, Orthodox, Lutheran, their construction funded by worker donations, often matched by company contributions. You could walk through South Bethlehem and hear a dozen languages, see Cyrillic signs next to Polish ones, smell paprikash cooking in one apartment, moussaka in another. This was industrial America, a melting pot in the most literal sense. People from across Europe, thrust together by circumstance, united by work. The rhythms of the city followed the plant's schedule. Bars opened at 7 almost a.m. to serve night shift workers getting off. Churches held masses at 6 a.m. and midnight. Schools scheduled around shift changes so fathers could walk kids to school. To say, "I'm from Bethlehem," meant steel. The city smelled like it, sulfur and smoke, the distinctive metallic tang of hot iron. The sky glowed orange at night from the furnaces. The ground vibrated with the hum of machinery. You could feel the plant even when you couldn't see it. Children grew up knowing the path. High school graduation, then the plant. That's what your father did. Your uncles, your older brothers, that's what you would do. It wasn't questioned. It was destiny. And for most of the 20th century, it was a good destiny. Bethlehem Steel paid better than almost any other employer in Pennsylvania. The work was hard, dangerous, exhausting, but it was steady. And steadiness meant everything. The company cultivated this loyalty deliberately. Bethlehem Steel marketed itself as more than an employer, as a community, a family. The company newspaper, the Bethlehem Steel Review, published monthly, featured worker profiles, safety tips, and company news. It emphasized the company's contributions to national defense, to infrastructure, to progress. The message was clear. You're not just making steel. You're building America. And the workers believed it, because it was true. Every major bridge, building, and ship constructed between 1900 and 1960 bore Bethlehem Steel. The Golden Gate Bridge, the Empire State Building, the aircraft carriers that won World War II, the workers had made those with their hands. That pride sustained them through the brutal work. They weren't just laborers, they were craftsmen, builders, Americans. But pride has a cost. It makes change harder to accept. It makes decline harder to bear. When Bethlehem Steel began to struggle in the 1970s, workers couldn't understand why. They'd done everything right. They'd worked hard. They'd been loyal. They'd built everything the company asked them to build. How could it all fall apart? The answer was simple and devastating. The world had changed, and neither the company nor its workers had changed with it. But in 1950, at the peak, no one could imagine decline. Bethlehem Steel seemed eternal. The company, the culture, the way of life, it would last forever, or so they thought. December 7th, 1941. Pearl Harbor. By December 8th, Bethlehem Steel had activated contingency contracts worth $500 million. The company had been preparing for war since 1939 when Germany invaded Poland. Now, preparation became execution. America needed ships, hundreds of them. Aircraft carriers, battleships, destroyers, submarines, troop transports, cargo vessels. The Navy's pre-war fleet was inadequate for a two-ocean war. America needed armor plate for tanks, artillery shells by the millions, steel for aircraft frames, railway tracks to move troops and supplies, structural steel for factories building weapons. America needed steel, mountains of it, and Bethlehem Steel delivered. Between 1941 and 1945, the company underwent the most intense expansion in its history. The Bethlehem plant added capacity faster than at any time since World War I. 3 new blast furnaces, 10 new open hearth furnaces, 2 new rolling mills. The plant operated at maximum capacity, 24 hours a day, 7 days a week for 4 straight years. Employment exploded. By 1943, the Bethlehem plant employed 31,000 workers, the highest in company history. Nationwide, across 15 facilities, Bethlehem Steel employed over 300,000 people. But there was a problem. The men were gone. 16 million Americans served in uniform during World War II. That included thousands of Bethlehem Steel workers, skilled operators, trained craftsmen, irreplaceable expertise, all wearing Army or Navy uniforms. The company's solution: hire women. This wasn't a progressive gesture, it was necessity. Production quotas had to be met. If men weren't available, women would have to do. Starting in early 1942, Bethlehem Steel recruited thousands of women for production roles previously closed to them: welders, crane operators, machine operators, quality inspectors. By 1943, women comprised 15% of the workforce. Nearly 5,000 women working jobs that had been exclusively male for 80 years. The Rosie the Riveter posters, many featured Bethlehem Steel workers. The company promoted them heavily in advertising, patriotic imagery of women building ships and tanks. But management was clear: this was temporary. When the war ended, when the men came home, the women would return to domestic life. This wasn't a permanent change. It was an emergency measure. The women proved extraordinarily capable. Accident rates in female staff departments were lower than male equivalents. Quality control metrics improved. Women had better visual acuity for spotting defects. Production targets were consistently met. None of this mattered. In 1946, when soldiers returned, nearly all the women were dismissed. Few remained in office positions. The rest were thanked for their service and sent home. But for 4 years, they'd proven something important. The work wasn't about physical strength. It was about skill, precision, and dedication. Women could do it as well as men. The lesson was forgotten almost immediately. Meanwhile, production reached levels that seemed impossible. Bethlehem Steel's output during World War II: 1,227 warships, more than any other American company. This included aircraft carriers, battleships, including the USS South Dakota and USS Indiana 125 destroyers, 40 submarines, hundreds of landing craft for amphibious invasions. The Fore River Shipyard in Massachusetts, owned by Bethlehem, set records for construction speed. A destroyer escort, normally requiring 9 months to build, was completed in 47 days. The entire shipyard worked like an assembly line, with prefabricated sections welded together in sequence. 15% of all American armor plate, the steel protecting tanks, ships, and fortifications. 65 million pounds of forgings for naval guns, artillery pieces, and tank cannons. 4 million artillery shells. Structural steel for thousands of factories building aircraft, vehicles, and weapons. The Bethlehem plant alone produced 5.7 million tons of steel in 1943, the peak year. That's enough steel to build 90 Golden Gate bridges, or frame 100,000 houses, or construct 500 warships. The financial results were staggering. Revenue in 1943, $1.3 billion, equivalent to $23 billion today. Profit, $45 million at the market share, 15% of all U.S. steel production. Bethlehem was second only to U.S. Steel in size. But in reputation, in quality, in public perception, Bethlehem was first. When Admiral Chester Nimitz toured the Bethlehem plant in 1944, he told workers, "You are winning this war. Every ship we sail, every shell we fire, every landing we make, you built the tools. This is where victory is forged." The workers believed it, and they were right. Bethlehem Steel's armor plate protected American tanks in North Africa, Italy, and France. Bethlehem destroyers hunted German submarines in the Atlantic. Bethlehem aircraft carriers launched planes that bombed Tokyo. Bethlehem Steel framed the B-17 bombers, the Sherman tanks, the landing craft that hit Normandy on D-Day. The company was indispensable, literally. Without Bethlehem Steel, the war effort would have faltered, and everyone knew it. Workers, management, government officials, the public, everyone understood Bethlehem Steel's role. The pride was immense. Workers bought war bonds with their paychecks. They volunteered for double shifts. They accepted housing shortages, rationing, and sacrifice because they knew their work mattered. On August 15, 1945, Japan surrendered. The war was over. Bethlehem Steel threw a celebration. 20,000 workers gathered at the plant. Speeches, music, fireworks. Eugene Grace, the company president since Charles Schwab's death, addressed the crowd. "We have built the weapons of victory," Grace declared. "Now we will build the infrastructure of peace. America will build like never before. Highways, bridges, buildings, cities, all of it will require steel, and we will provide it." The crowd roared approval. Grace was right about the building boom. The 1950s and 1960s would see enormous construction, the interstate highway system, suburban development, commercial real estate. But Grace was wrong about something crucial. He believed demand would remain unlimited, that prices would stay high, that Bethlehem's dominance was permanent. The war had been good for Bethlehem Steel. Too good. The company had grown accustomed to cost-plus contracts. The government paid production costs plus a guaranteed profit. There was no incentive to cut costs or improve efficiency. If something cost more, you just charged more. This mentality would persist into peacetime. And in peacetime, customers had choices, competitors had advantages, the market was unforgiving. But in August 1945, standing in front of cheering workers, Eugene Grace couldn't see any of that. Bethlehem Steel had just helped win the greatest war in human history. The company stood at its absolute peak, in size, in reputation, in financial strength, in cultural importance. This was the moment of triumph, the summit, the cathedral completed. It was also the beginning of the end. The cathedral had been built on foundations of wartime demand, government contracts, and unquestioned American industrial dominance. All three of those foundations were about to crack. October 1973. OPEC, the Organization of Petroleum Exporting Countries, imposed an oil embargo on the United States. Oil prices quadrupled within months, from $3 per barrel to $12. For most Americans, this meant expensive gasoline and long lines at service stations. For Bethlehem Steel, it was catastrophic. Steel production is extraordinarily energy-intensive. Heating blast furnaces to 3,000 degrees requires massive amounts of power. Running electric arc furnaces, operating rolling mills, powering the entire complex, all of it consumed energy in staggering quantities. Before 1973, energy was cheap. After 1973, it wasn't. Bethlehem's energy costs increased 300% in 18 months. The company's electricity bill, previously $2 million per month, jumped to $6 million. Natural gas costs tripled. Coal prices doubled. Profit margins evaporated overnight. But energy wasn't the only problem. It was just the most visible symptom of a deeper crisis. Three forces converged in the 1970s to devastate American steel. First, foreign competition. Japan and West Germany had rebuilt after World War II, rebuilt with American aid, ironically, and they'd built modern steel mills, continuous casting technology, computer-controlled furnaces, automated rolling mills, equipment designed in the 1960s and 1970s, not the 1920s. Japanese steel mills operated at 40% greater efficiency than American mills. They could produce a ton of steel for $280. Bethlehem's cost $380 per ton. The Japanese weren't just competitive, they were cheaper, and their quality was excellent. By 1975, imported steel accounted for 12% of U.S. consumption. By 1980, it would reach 25%. American steelmakers were losing market share in their own country. Bethlehem Steel's management blamed unfair trade practices. Japanese companies received government subsidies, they argued. Currency manipulation gave them artificial advantages. They were dumping steel below cost to capture market share. All of this was partially true, but it was also an excuse. The fundamental problem was simpler. Bethlehem's facilities were old, and the company had underinvested in modernization. Second, automation and mini-mills. A new type of competitor emerged in the 1970s, the mini-mill. Traditional steel mills, integrated mills like Bethlehem, started with iron ore and produced steel from scratch. This required blast furnaces, open hearth furnaces, enormous capital investment, and thousands of workers. Mini-mills started with scrap steel, recycled metal from demolished buildings, junked cars, old appliances. They melted it in electric arc furnaces and rolled it into products. No blast furnaces needed, no ore boats, no coking ovens. Mini-mills were smaller, faster, more flexible. They could be built near customers, reducing transportation costs. They required 1/10 the capital investment of an integrated mill. And they employed far fewer workers. A mini-mill producing 500,000 tons per year employed 200 people. Bethlehem needed 3,000 workers to produce the same amount. Companies like Nucor pioneered this model. By 1980, mini-mills had captured 20% of the American steel market. Bethlehem couldn't compete. The company's entire business model, massive integrated production, was becoming obsolete. Third, the pension crisis. Bethlehem Steel had promised generous pensions to generations of workers. $100 per month after 30 years of service seemed reasonable in 1940. It still seemed reasonable in 1960. But by 1975, Bethlehem had 80,000 retirees receiving pensions. Most lived longer than actuarial tables predicted. Modern medicine extended lifespans. The pension fund had to support them for 20, 30, even 40 years after retirement. The numbers were staggering. In 1970, Bethlehem's unfunded pension liability, the gap between what had been promised and what had been saved, was $200 million. By 1980, $1.2 billion. By 1990, $2.8 billion. Every dollar needed to fund pensions was a dollar not available for modernization. The company was trapped between honoring commitments to past workers and investing for future competitiveness. Wall Street offered no help. Banks wouldn't lend for long-term capital projects when the company was already struggling with debt. Shareholders demanded quarterly profits, not decade-long modernization plans. Bethlehem was caught in a vicious cycle. Underinvestment led to lost market share, which led to reduced revenue, which led to more underinvestment. The company's response was predictable: cut costs. In June 1975, Bethlehem Steel announced 3,500 layoffs at the Bethlehem plant, the first major layoff since the Great Depression. For workers, this was incomprehensible. The company was still profitable, barely but profitable. Orders were down, yes, but they'd been down before. Bethlehem had always weathered downturns. This felt different. Frank Demchak, the youngest worker in the cold open, remember him, was 45 years old in 1975. He'd worked at Bethlehem for 27 years, married, 3 kids, a mortgage on a house bought with the assumption of steady employment. When the layoff notice came, Frank didn't believe it. There had to be a mistake. There wasn't. "We believed the company would take care of us," Frank said years later in an oral history interview. "We'd given them our lives, our health, our loyalty, and they gave us pink slips and 2 weeks severance." The laid-off workers had few options. Other factories weren't hiring. The entire economy was in recession. Moving meant uprooting families, selling homes in a collapsed market. Retraining at age 45 or 50? With what money? Most collected unemployment and waited. Hoped the layoffs were temporary, hoped they'd be called back. Some were, most weren't. The psychological impact was devastating. These men had built their identities around being steelworkers. It wasn't just a job, it was who they were. Take that away, and what remained? Depression rates among laid-off steelworkers spiked. Divorce rates increased. Alcoholism. Several suicides were linked directly to job loss. The social safety net was inadequate. Unemployment benefits lasted 6 months. After that, nothing. Families burned through savings, fell behind on mortgages, lost homes. South Bethlehem began to decay. Businesses closed, bars, shops, restaurants that had depended on steelworker wages. For sale signs appeared on houses and never came down. This was just the beginning. Between 1975 and 1985, Bethlehem Steel would cut 15,000 jobs from the Bethlehem plant. From a peak of 31,000 workers to 16,000, each round of layoffs followed the same script. Management announced restructuring. Workers were angry, then resigned. The union protested but had little leverage. You can't strike when the company is barely profitable. Some engineers at Bethlehem saw the crisis clearly and wrote internal reports. "Our facilities are 40 years old. Foreign competitors operate at 40% better efficiency. We must invest billions in modernization immediately or face obsolescence." Management's response: "We've been making steel for 120 years. We'll weather this." This was the turning point, the moment when aggressive investment might have saved the company. Instead, they chose survival mode, cut costs, delay maintenance, squeeze every dollar from existing facilities. It was a decision to die slowly rather than transform boldly. The cathedral was beginning to crumble, and no one knew how to stop it. The decline wasn't dramatic. It was grinding, relentless, demoralizing. Layoffs became routine, almost predictable. 1977, 1 in 200 workers. The excuse, reduced demand for structural steel. 1982, 2,800 workers. The excuse, recession. The worst economic downturn since the Great Depression hit that year. Construction halted. Auto production collapsed. Steel orders evaporated. 1986, 1,500 workers. The excuse, foreign competition. 1991, 3,200 workers. The excuse, another recession. 1993, 1 out of 800 workers. The excuse, restructuring. By 1995, only 7,000 workers remained at the Bethlehem plant, down from 30,000 in 1943, down from 26,000 in 1970. Each round of layoffs followed the same script. Step 1, management announces necessary workforce reductions due to current business conditions. Step 2, workers receive 2 weeks' notice. Severance, 2 weeks' pay per year of service, capped at 1 year's pay. Step 3, exit interviews with HR. Return your tools, your safety equipment, your ID badge. Step 4, walk out the gate. After 20, 30, 40 years, just walk out. No ceremony, no thank you, no recognition of decades of service. "I gave them my back, my hearing, my health," said Tony Buba, who was laid off in 1986 after 33 years. "They gave me $18,000 and showed me the door." The older workers took it hardest. Men in their 50s and early 60s, too young to retire on reduced pensions, too old to start over. They'd spent entire adult lives doing one thing, making steel. Now, that skill was worthless. Where do you go at 55 with a body worn down by decades of physical labor and skills that only apply to an industry that's dying? Some found work at other factories, taking pay cuts of 30 to 40%. Some retrained at community colleges, computer skills, HVAC repair, truck driving. The success rate was mixed. Many never worked again. They collected unemployment until it ran out, burned through savings, applied for disability if their bodies were broken enough to qualify. Some took early Social Security at reduced rates. The psychological toll was immense. These men had built their identities around being Bethlehem Steel workers. They'd been proud of it. They'd defined themselves by it. Take that away, and what's left? Depression became epidemic among displaced workers. One study in the late 1980s found that former Bethlehem Steel workers had rates of clinical depression 3 times higher than the general population. Divorce rates spiked. Financial stress destroyed marriages. Men who'd provided for families for decades suddenly couldn't. The shame was crushing, and the deaths. Several suicides were directly linked to layoffs, heart attacks, strokes. One researcher calculated that displaced steelworkers died, on average, 7 years earlier than those who kept employment. The work had been killing them slowly for years. The heat, the fumes, the physical strain. But at least it had meant something. At least they were building things, providing for families. Without the work, they were just dying. Faster. The younger workers, those in their 30s and early 40s, had better outcomes. They could adapt, retrain, start over. It was painful, but possible. But it was still betrayal. They'd been promised a career, a future. Their fathers had worked at Bethlehem. They'd followed that path, believing it was secure. It wasn't. Meanwhile, the plant itself decayed. Buildings that once gleamed with fresh paint now rusted. Windows broken and never repaired. Equipment maintained minimally. Fix what breaks, but don't upgrade. The grounds grew weedy. Parking lots developed potholes that became craters. Entire sections of the complex shut down. Blast Furnace B decommissioned in 1982, Furnace F closed in 1985. Rolling Mill No. 4 shuttered in 1989. The remaining workers saw it happening. They knew. Everyone knew. The company was slowly liquidating itself. And yet, they kept coming to work. What else could they do? Those who remained worked harder than ever, trying to prove the plant was still viable. If we're more productive, maybe they won't close us. If we meet every quota, maybe we'll survive. It didn't matter. The fundamentals hadn't changed. Bethlehem Steel had approximately $5 billion in debt by 1990. The interest payments alone consumed most profits in good years. In bad years, the company lost money. The pension crisis worsened. By 1995, Bethlehem had 100,000 retirees and dependents receiving benefits. Only 20,000 active workers. The ratio had flipped, 5 retirees for every active worker. The math was unsustainable. The company stopped investing in modernization entirely. Between 1985 and 1995, capital investment at the Bethlehem plant totaled less than $100 million. Competitors were spending billions. Why didn't Bethlehem invest? Simple. They couldn't afford to. Every dollar went to debt service, pension obligations, and basic operations. There was nothing left for transformation. Some historians argue Bethlehem could have been saved with aggressive government intervention. Loan guarantees, trade protection, pension relief. Maybe. But such intervention never came at the scale needed. Other historians argue the company's fate was sealed, that integrated steel mills were dinosaurs, that no amount of investment could match mini-mill efficiency or offshore production costs. This view has merit. The truth probably lies between. Bethlehem made poor decisions, waiting too long to modernize, underestimating foreign competition, maintaining unsustainable labor costs. But they also faced forces largely beyond their control: globalization, technological disruption, massive legacy obligations. What's certain is this: by the early 1990s, everyone knew the end was coming. The only question was when. Workers watched the plant die around them, each closed furnace, each demolished building, each round of layoffs. The community watched too. South Bethlehem hollowed out. Population declined as workers moved away seeking employment. The commercial district, once vibrant with 47 bars and dozens of shops, became a ghost town. Buildings empty, windows boarded, for sale signs that never came down. Property values collapsed. Homes that sold for $120,000 in order couldn't find buyers at $60,000 in 1995. Some owners just walked away, letting the bank foreclose. The city's tax base eroded. Bethlehem Steel had once provided 40% of municipal revenue. By 1995, that was down to 8%. City services were cut. Schools struggled. Infrastructure decayed. It was a death spiral. The plant's decline caused community decline, which made the plant less attractive as an employer, which accelerated its decline. On November 18, 1995, Blast Furnace C tapped its final heat. The last pour. The last time molten steel would flow from a Bethlehem furnace. Jack Morrison opened the tap at 11:47 p.m., just like we saw at the beginning of this story. The steel flowed for 23 minutes. Then it was over. The furnace that had run continuously since 1914, 81 years without stopping, went cold. The Bethlehem plant would continue operating fabrication and finishing operations for a few more years, working with steel made elsewhere. But steelmaking in Bethlehem was finished. The cathedral was empty. The fires were out. What remained was just the slow work of dismantling, selling off assets, liquidating inventory, processing bankruptcy paperwork. The end, when it finally came, would be anticlimactic. No drama, no last stand, just quiet closure. But that's next. After the last pour in November 1995, Bethlehem Steel limped forward for 6 more years. The plant continued operating, but not as a steelmaker. It became a fabricator, a finisher. Steel came from other mills, sometimes from competitors, sometimes from overseas. Bethlehem workers cut it, shaped it, assembled it, shipped it. It was humiliating in a way that's hard to articulate. These were steel makers. Their identity was forged in the blast furnaces. Now they were just processors, middlemen. Employment continued to decline. 5,000 workers in 1997, 3,000 in 1999, 1,500 in 2001. The The company lurched from crisis to crisis. In 1998, Bethlehem Steel filed for bankruptcy protection. Debt, $4.5 billion. Unfunded pension obligations, $3.7 billion. The company was technically insolvent. Liabilities exceeded assets by billions. But bankruptcy protection allowed operations to continue. The courts froze debt payments. Creditors couldn't force liquidation. The company had breathing room. Not much, but some. For 3 years, Bethlehem Steel operated under bankruptcy protection. Restructuring plans were drafted, revised, abandoned. Potential buyers looked at the assets and walked away. Too much environmental liability, too much pension obligation, too little salvageable value. Then came September 11, 2001. The terrorist attacks devastated the American economy. Construction projects were canceled. Steel demand plummeted. Companies that might have considered buying Bethlehem Steel assets disappeared. On October 15, 2001, Bethlehem Steel Corporation announced it would cease all operations. 144 years of steelmaking. Over. The final day, October 15, 2001, was quiet. 400 workers remained on payroll, mostly administrative staff, a skeleton crew maintaining empty buildings while bankruptcy proceedings finalized. At 4:00 p.m., the last workers clocked out. No press conference, no media coverage. The nation's attention was on terrorism, war, homeland security. A bankrupt steel company in Pennsylvania wasn't news. A few hundred former workers gathered at the gate. They stood in silence. Some had worked there 40 years. Some were second-generation, third-generation steel workers. Their grandfathers had helped build Furnace C in 1914. Now they watched security guards lock the gates. One worker, his name lost to history, spray-painted on the fence, "We built America." It was true, and it didn't matter. Within a week, scrap dealers began dismantling equipment. The valuable metal, copper wiring, stainless steel components, was stripped first. Then, the structural steel itself. Cranes that had lifted 100-ton ladles were cut apart and sold for scrap. Ironic in a way. Bethlehem Steel built with steel. Now it was being melted down, recycled, reborn as something else. Within a month, windows were shattered. Vandals spray-painted graffiti. Urban explorers snuck in to photograph the ruins. The industrial decay aesthetic was popular online. Within a year, the site looked post-apocalyptic. Collapsed roofs, rusted equipment, weeds growing through cracked concrete. The blast furnaces stood empty, their brick interiors crumbling. The cathedral had become a tomb. Jack Morrison, remember him? The foreman who tapped the final heat in 1995, retired 2 weeks after that last pour. He was 62 years old, 41 years at Bethlehem Steel. He received a plaque. In recognition of 41 years of dedicated service, no ceremony, no handshake from executives, no pension bump, just a piece of engraved brass and a form letter. Jack had expected something. A speech, maybe. Recognition that he'd been there at the end, that he'd closed the book on 141 years of history. "I thought there'd be something," he said in a 2005 oral history interview. But there was nothing. They turned off the lights and locked the gates. Jack died in 2009 at age 74. The cause was listed as complications from chronic obstructive pulmonary disease, lung disease from decades of breathing steel dust and furnace fumes. His obituary mentioned his 41 years at Bethlehem Steel before listing his survivors. His family asked if someone from the company, or its successor, ISG, which had purchased some assets, could attend the funeral. No one came. This pattern repeated hundreds of times. Workers who'd given decades died from occupational diseases. Families requested company representation at funerals. The answer was always no. The company no longer existed. The successor companies felt no obligation. The pension crisis finally resolved, brutally. In 2003, Bethlehem Steel Corporation was officially dissolved. All pension obligations transferred to the Pension Benefit Guarantee Corporation, a federal agency that insures pensions. The PBGC had limited funds. It couldn't honor the full promises Bethlehem had made. Retirees saw their pensions cut by 20 to 30%. A worker who'd been promised $200 per month now received $850. A worker promised $800 now received $580. For retirees living on fixed incomes already struggling, this was devastating. They'd worked 30, 40 years based on a promise. The promise was broken. "They stole from us," said Maria Santos, who'd worked at Bethlehem for 24 years before being laid off in 2000. "We gave them our lives, and they stole our retirement." Legally, it wasn't theft. The pension fund was insolvent. The PBGC did what it could with available resources. But to the workers, it felt like theft. Some filed lawsuits. They lost. Bankruptcy court rulings were clear. Unsecured creditors, which included pension claims, were at the bottom of the priority list. They got pennies on the dollar. Others applied for food stamps, Medicaid, social services they'd never imagined needing. The psychological impact was crushing. These were people who'd taken pride in self-sufficiency. They'd worked hard, played by the rules, and ended up poor anyway. Meanwhile, former Bethlehem Steel executives received millions in severance packages. The CEO, when the company declared bankruptcy, walked away with $4.2 million. The contrast was obscene, and workers noticed. "The guys at the top got rich," Tony Buba said in 2010. "The guys who built the steel got nothing. That's America." The site itself remained empty for years, contaminated with decades of industrial residue, lead, asbestos, PCBs, heavy metals. The cleanup cost was estimated at $50 million. No developer wanted to touch it. Finally, in 2007, a partnership between the city, state, and private developers announced Steel Stacks, a plan to preserve 5 blast furnaces as historical monuments and build a cultural campus around them. Skeptics said it would never work. Who wants to visit abandoned factories? But it did work. Today, Steel Stacks hosts concerts, festivals, exhibitions. The blast furnaces, illuminated at night, have become the symbol of Bethlehem's reinvention. It's bittersweet, beautiful in its way. The ruins have become art. But for the workers who built those furnaces, who worked in that heat, who gave their bodies to that steel, it's complicated. They're glad something remains, glad the furnaces weren't demolished entirely. But walking through Steel Stacks, seeing tourists photograph the ruins, hearing people talk about industrial aesthetics, it hurts. This isn't art. It's their lives, their sacrifice, their broken promise. The cathedral stands empty, the fires are cold, the machines are silent, and the men who built it are dying, forgotten.